Hello, this is Brett from Survivalcomms, and on the workbench today we have a Zenith Transoceanic Royal D7000. I've wanted one of these radios for years, and I picked this one up at Florida Flywheelers really inexpensively. And these radios are an AM broadcast band, FM broadcast band, shortwave band receiver, and they also pick up the VHF weather band. The log scale is tied into the band select switch, so you can see here how that moves along. Your tuning movement is here. It does have a beat frequency oscillator, so we'll pick up single sideband.
Test 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
And it also has a battery level indicator, and it runs on D-cell batteries, and it also runs on AC power. This radio is completely solid state. There are no tubes in it. Although this radio is of solid state construction, it is representative of a bygone era of tube type radios which utilized point-to-point wiring in its construction rather than printed circuit boards. And this was the last of the Transoceanics that did such. The model that superseded it, which was the last in the Transoceanic line, the R7000, used printed circuit boards in its construction. The Zenith Transoceanic line ran from 1942 up until the early 80s, and during that time it was considered to be one of the premier portable shortwave radios. You can see the top of it here, how we can see what time zone, which is important when you're doing shortwave listening, because certain stations would broadcast on certain frequencies at certain times of the day, so it was very important to know exactly what time so you could utilize the broadcast schedules to best effect. Again, this is your band switch and your different log scales as we're stepping through them. You have this slider right here, so if you find a station you're interested in and you want to save its location. Control wise, we have our volume control, we have a tone control, we have our RF gain, which has got a automatic setting and then a manual RF gain control. We have a beat frequency oscillator, which allows us to monitor single sideband. We have this switch, which does basically FM and AM. And we have a bandwidth switch, which would do your narrow and wide. And down here, you can see it has a battery indicator when pressed. This way it would tell you what the battery level is, and this way would be a tuning indicator. Here is your tuning knob here. And this has a chart light. And at the bottom here, you have this little fold-out tray that has a compass rose on it for your convenience. And you also have, interestingly enough, this still has the basic instructions and a list of shortwave schedules. This also does the long wave beacons too, by the way, which is really cool. Kind of like those old DF radios. So you can see these are your marine broadcasts here. And here's your shortwave broadcasts. And in reviewing these shortwave schedules here, this kind of gives you an idea of the vintage of it. You can still see that there is a Voice of Vietnam from Hanoi and Radio Vietnam from Saigon. So this lets you know that this radio was produced, or this particular book was produced, before the fall of South Vietnam. The back side of the radio, you have a telescoping whip. It's enclosed in this housing here. It's rather long. It also has an internal bar antenna, of course. Remove our cover. You can see that there's not a lot of evidence of corrosion from the batteries, which is a good thing. And you have these sleeves that would encapsulate the D-cell batteries. You have this where you can hook up an external antenna. And this is where you hook up the AC adapter, which it's nice that this one includes the AC power cord. And you can see the model of the radio, and you can see all of your other location of all your 18 transistors within this radio, and then also a property tag. And you have to consider that this radio is a product of the time when consumer electronics were not disposable items as they are now. And the cost of this radio at the time was expensive enough to warrant you hanging on to it for a length of time. when you would hook up your power cord, you could certainly do it with a cover on there. But you can see this slider goes back and forth and exposes the pins to connect your AC plug adapter. Let's go ahead and light it up. And we've got hum, max RF gain, tone squared away, volume's all the way up, no lights there. AM broadcast band is dead. Looks like we have FM. See if we have our weather radio. Doesn't look like it. We've got some issues, so let's take this thing apart and see what we can come up with. Okay, now we're going to take it apart after the back cover is removed, secure power from it. And there are 3 screws at the base here. And we'll just go ahead and remove those first. This side here. So plug that antenna lead, slide this cover off. On the inside here, see there's a power connector here. I'll uncouple that. Then you also have this plug for the tuner here, external tuner it looks like, it's an RCA of some kind. And that's not easy to get out, but it's coming out. So now we've separated this. You can see that we've got our power supply right here, and that plug right there, and our antenna, and this is the connector for that. You can see the inside the back of the chassis. You can see our transistors kind of hanging in space here, and these are original transistors. Someone's been in here and changed out a bunch of stuff at some point or the other, so we're going to have to go ahead and pay attention to that when we're servicing it. There is some corrosion evident on the chassis, and there's also some corrosion here on the tuning movement itself. And you can see a couple more of our transistors right there. And if I'm not mistaken, that's your FM section of the radio right there. So what we're going to do now is remove all the knobs from the chassis, and then there's screws. There's 2 screws on this side here, and then these screws right here. And then it'll enable us to remove the radio chassis from the housing itself. Now we're just going to go ahead and remove our knobs. I'm just going to use a popsicle stick here because I don't want to mar up the radio itself, and apply a little bit of force to this to get the tuning knob off. Once you get behind it, it comes off just like that. These smaller knobs, if you see my video on the preparing LDF450A cable and putting RF connectors on it, this is the prep tool to remove the insulation. And this is the proper size to pull these knobs off here without marring the surface as well. You can kind of see that right there, just like that. Okay, once we've stripped all the knobs from the front of it, we need to remove the knob for the tuning selector here. And to remove our band select switch, you can see there's a small set screw on the shaft of the knob itself, and we're just going to have to use an Allen wrench to remove that screw. Okay, now that we have that out of the way, we have a screw here that we need to remove, and there's another one that's right above it, right by where you remove that set screw from. Then on this side of the radio, you have some more screws here. You'll remove this screw on top of the output transistors, and then this bracket right here should come out. Shape kind of like that. And now we should be able to kind of rotate the housing out. Just like that. Aha. Your map light or chart light plugs into right here and comes just disconnects just like that. And out of the way. And the speaker connections, you can see right here, one's already pulled loose. Come out just like that. Now we can set our housing separate from our radio itself. You can see in the housing itself that we have layers of funk that we're going to have to get out of there, and then you can also see that we do have a small perforation in the speaker cone. And here is the front side of the radio removed from the housing, and my oh my, look at that, all that stuff's hand soldered. No machines are putting these things together. Man, look at all of that. You want to see something really cool? Look at this band switch, man. Look at that. That's just amazing. It really is. I'm going to hate to have to go through all of that. And this, I thought this stuff might have been burned up, but that just was potted together. Looks like this capacitor and this resistor here were just potted together at some point. What I've done is I've built myself a test jumper running to a speaker down here on the floor to keep it out of the way. I added some Cat 5 cable. I've got tied into here, so I've got my speaker squared away, and then I built a power connector here that just plugs into my benchtop power supply. So this way I can actually test the radio without having to put the housing and all that other stuff on there. And I've cleaned out the housings and got the funk out of them. And if you're working on one of these radios, whenever you're cleaning the plastic parts of it, remember, you don't ever want to clean it with anything that's stronger than what you would clean yourself with. So we've got the radio. I've cleaned out the band switch. We've got it hooked up. We can just turn the radio on now. And you can hear it receives good on FM. It's got plenty of audio, so we're good in that. But when we go to broadcast band AM here, you can see we've got nothing at all. So what we're going to do is we're going to test to see if our local oscillator is working. So we're going to go down to about 600 kilohertz on this receiver here. And then you've got a small AM receiver, which in this case is my VX3R. And what we can do is we can tune around here. You can see how we quiet and how our signal goes up. You can hear that heterodyne noise there. So what that's showing us is that the oscillator is working in this radio. And we've got another issue, reason why it's not receiving AM. Now, I have the service instructions for this radio. And whenever you're working with any piece of electronic equipment, it's extremely important if you can get the service instructions, the service manual, the schematics to affect any kind of repair or troubleshooting. It makes it so much easier. I mean, yes, generic stuff that's obvious and stands out, or something that could be found very easily, but as far as anything, detailed troubleshooting without documentation, it's extremely difficult to figure out. So we've got some test point voltages here. And it's supposed to be AM without the signal, so we're going to take our DC multimeter here and we're going to hang it on the chassis for the ground side of things. That would be good right there. And our first test point voltage with no signal is supposed to be 1.75, and that's a little over 196. Next supposed to be 2.5, and no good there. Next is supposed to be 0.03, so we're a little high there. 1.8 is supposed to be this test point, a little over. 0.2, so we're a little under. 5.4, and we're a little over. And 5.2. So the one we're failing is this one right here. Oh, there we go. Just a little corrosion action on there. It's 2.7, so it's a little bit high. So let's keep on trucking. We're going to go ahead and change out Q101 and Q102, and there's a Q103 we're going to change out too. Okay, so Q101 is right here, and it's pretty easy on these. These are socketed, so you just kind of doink, pull it right out. Sit on there, you can see the EBC right there. All right. The replacement for that is going to be this right here, which is this 194 transistor. You can see it's emitter base collector, which essentially follows the same as this one here. So let's go ahead and shorten our legs on our transistor here. And we don't want them to be too incredibly long. And let's see, we'll try to see if I can zoom you in. And what we're going to do is we're just going to plug this into right here. And we're good as new with that one. Our next two that we're going to replace are right here, and they're underneath that wave rod antenna. And we'll go ahead and pull Q102 first. Get that out of here. And you can see our original transmitter or transistor is a base emitter collector arrangement, and our replacements are emitter base collector. So we're going to have to move around some pin legs. I've moved my base and emitter around. I've applied a small piece of insulation from a piece of hookup wire that I removed the insulation from. And this is going to protect the pins, since I'm moving them around, from shorting against one another and being inoperative. So plug it in the same spot as the original transistor, and we should be good there. Okay, well, we've got our transistors replaced in the AM section, and turning it around here, plug our power back in, and let's see if it worked. Oh wow, look at that. We have AM. You have a nasty 60 hertz hum, it sounds like, but see our tuning indicator is working again. So we've got broadcast band back. Let's see if we got shortwave. Sounds like it. Now I'm going to test the light on the log scale while I'm at it with my high-tech testing tool here. And you can see it come on. So our bulb is good inside of that. So we don't have to disassemble our bulb in here. Now that we've got it working again, I've been taking contact cleaner and cleaning the band switch, and I've cleaned all the potentiometers here and the sliding switches. And what I do is for the tuning capacitor, the blades of the capacitor, I just basically take an envelope, fold it in half, and I use the envelope and just go between each blade and clean out all the dust. I don't like to use chemicals in there. I would much rather just do it manually like this, and it is very tedious to do that. But you get a considerable amount of grunginess out of the plates of that capacitor by doing that. Now we're going to align the radio. A radio is essentially a whole bunch of tuned circuits and amplifiers, and what we're going to do is we're going to tune those tuned circuits. See me do simple alignments and stuff with commercial two-way stuff. That's really easy with a computer. With this stuff here, you align everything manually by using those tuning tools that aren't so common. So we're going to start up here at the AM broadcast band. We're going to work down through FM, and then we're going to end up with the shortwave spectrum down here. And it's a tedious process, and I won't subject you to all of it, but we'll do little tidbits here and there. So what we're doing is we're injecting a 455 kilohertz signal into the radio on a particular test point. and then we're going across the speaker terminals to my AC millivoltmeter here. And what we're doing is we're adjusting for maximum signal in a variety of inductors. Okay, this is what we're working on here. What we're working on is setting shortwave 2 oscillator to scale. So we set it for shortwave 2 as our band. We set our signal generator for 8.75 megahertz, and we set our dial for 8.75 megahertz. And you can see there's nothing. So what we do is we look around for where, and you can see that's where our signal is residing. So what we're going to do is we're going to put that signal at that position on the dial. So we go to 8.75 megahertz, and we turn around, and using our chart here, we need to adjust capacitor 114 echo, which is this bottom one in this row, which is right here. So what we do is just put our tuning wand on here and turn it until we start to pick up our signal. And there we have it. Well, now that we're aligned, we're ready for reassembly. Okay, here on the Survivalcomms radio testing range, testing our long wave, and we're picking up the beacon in Key West. You can hear them on 300, I think it's 333 kilohertz.
The CD album of the series on love, the greatest thing in the world. Also, please include... I couldn't get much of what you were saying, but I could tell that you did turn it back to me, so I'm going to say 73. I'm going to say 73. And thanks for the QSO. Hopefully we can do it again soon. Hopefully we can do it again soon when the band is back up again. Sorry about that, but the band has changed, as you well know. 73, they're paid. Temperature 2 points, minus 9er. Altimeter 29er 73. Wait, there it is on sideband. Repeating aviation weather. Repeating aviation weather. Shear water. Shear water. No report received. Inlet. 18 nautical miles east of Fort Pierce Inlet. 9 nautical miles east of St. Lucie.
You're not quite ready to replace your current truck or SUV. Or maybe you're not typically a Ford owner. It doesn't matter. This sale is for you. Sheer maintenance.
It works. Crest. Health.
And the fans are you. Your hands will be so filled with wings. Hi, good morning, Max.
Florida man arrested for beating his mother with sausages.
Oh, no.
This hour was paid for by the host.
Well, there you have it, the last of the Zenith Transoceanics. I'm very pleased to add this radio to my collection, and I'm very pleased with how the repair came out. If you ever come across one of these in your travels, do not hesitate to pick it up. They're a fantastic radio. And I'm saving the world one radio at a time, but it's a lot of work. I hope this helps. This is Brett from Survivalcomms. Till next time.